Hello everyone. Hello everyone. Myself ML Narasimha. Welcome to all aspirants. Today we are discussing few standard models from signal subject related to ISRO examination. Let us see few questions. What is this? Data given. In digital filters, how many interpolated data points are inserted between samples when performing 4 times over sampling? When you want to increase the rate by 4 times, how many number of zeros are inserted in between? Let us take a simple example. Suppose x of n data is 1, 2, 3. For x of n by 4. Because you want to interpolate 4 times over sampling means interpolate it. We are inserting 3 zeros in between. We are inserting 3 zeros. So for x of n by m case, m minus 1 zeros are inserted between two values. For x of n by m case, where m is an integer, m minus 1 zeros are inserted. So that is 3 samples because it is given as 4 times over sampling. What is this data? Two LTI systems are connected. On the lower side, they have been interchanged. 2 blocks are interchanged. If system 1 and system 2 are LTI system and the same input is provided, out of these 2 statements, we have to decide which is valid one. So let us verify by taking a specific example. Assume, for understanding purpose, assume h1 of n as del of n minus 1 and h2 of n as del of n minus 2. For verification purpose, assume like that. h1 of n is del of n minus 1, h2 of n is del of n minus 2. So when you see the upper block diagram, we are choosing this as del of n minus 1. So here it is named as Fn. What is the second system we want to consider? Del of n minus 2. We assumed the output as y1n. What is x of n convolved del of n minus 1? So f of n can be selected as simply x of n minus 1. X of n convolved del of n minus 1. That is f of n. Similarly, what is y1 of n? F of n convolved. It is like f of n convolved del of n minus 2, that result is f of n minus 2 indirectly, because fn is x of n minus 1, that becomes x of n minus 3. X of n minus 3. But let us observe the lower one, lower block diagram, where the LTI systems are connected in series. Here we are choosing del of n minus 2 as second system. Here we are choosing del of n minus 1. What is the output g of n we can write here? What is the output g of n we can write? It is x of n convolved del of n minus 2 means x of n minus 2. It is x of n convolved del of n minus 2. But what is y2 of n? G of n convolved. G of n convolved del of n minus 1, that means g of n minus 1, which is simply x of n minus 3. As we know, g of n is x of n minus 2. So when you see, the final outputs are identical, not the middle outputs. y1 and y2n both are identical. Here we got y1 of n as x of n minus 3. Here we got y2 of n as x of n minus 3. final outputs are identical. So statement 1 is always true, not the middle one. Because if you see f of n, what is f of n? Result we have written x of n minus 1, g of n is x of n minus 2. Generally, when we interchange the LTI system for a common input that is applied, final outputs are identical, not the middle one. When you interchange the LTI system blocks for a common input that is applied, final outputs are identical. So statement 1 is always true. Statement 1 is always true. So let us verify the next model. So this is also one of the very good question asked directly from standard textbook OpenM Nawab in ISRO exam. X of t is 1 for 0 to t, h of t is a t for 0 to 2t. If y of t is xt convolved h of t, if y of t is xt convolved h of t, what is the output expression for a specific range t to 2t? What are the limits of output? X of t graph is having constant amplitude for 0 to capital T range. H of t is like ramp. It is like ramp. So what are the limits of y of t? Sum of lower limits 0, sum of upper limits t plus 2t. So 0 to 3t the output exists. Output is expected for which range? T to 2t. So when you recollect that convolution definition, one of the signal must be folded and shifted. First we have to change the axis x tau with respect to tau, x of tau with respect to tau. I want to take folded version of that one, which is minus t to 0. What is x of t minus tau means? For that adding t from the folded signal to get shifted signal, we have to add the variable t. So we have to find out the overlap of x of t minus tau and h tau, that too for a specific range. What is the range expected? What is the range that is expected is t to 2t. Let us see how it can be observed. Let us see how it can be observed. So let us assume a specific case, because you want to multiply which functions here? X of t minus tau and h of tau. X of t minus tau and h of tau. So which signal remains same in its position? The signal h of tau remains in its position, which is covered from 0 to 2t range. How to take overlap is, we are expecting output only for which range? Capital T to capital 2t. Capital T to capital 2t. So let us assume a specific case, t minus t greater than 0 but small t less than 2t. T minus t, this t minus t may be entering positive zone but still is less than the upper limit of h of t. So t minus t greater than 0 but t less than 2t. Then let us see what will happen. T minus t is greater than 0 but small t is less than 2t. Small t is less than 2t. So where you got overlap? You got overlap for certain portion, t minus t to t range. T minus t to t range. So when you simplify this, t is greater than t but t is less than 2t, that means overall range is t less than small t less than 2t. So y of t is according to convolution definition, we are integrating from t minus t to t, t minus capital T to t range, xt amplitude, that shifted signal amplitude is 1, h of t is given as a small t. H of t is given as small t, means we should take tau. We should take tau. So this is like tau square by 2. When you substitute the limits, that is going to simplify it as this option, tt minus t square by 2. After substitution of the limits, the answer is simplified like tt minus t square by 2. That is the output answer for the range capital T to capital 2t. First you take x of t, h of t graph according to thumb rule, limits of output are 0 to 3t. Our answer is expected for t to 2t range. General convolution method, we have to fold and shift one of the signal. Here I have taken folded and shifted version of x of t. According to the definition of convolution, we got that result, tt minus t square by 2. Okay. This is a very easy model. Consider the discrete time signal x of n given by some set of samples, and y of n is denoted as convolution of del n minus 1 and xn, means what is yn? What is standard convolution property of impulse? xn convolve del of n minus n naught means x of n minus n naught. In the question it is stated y of n is x of n convolved del of n minus 1. Answer is simply x of n minus. Answer is simply x of n minus 1 based on the convolution property of impulse function. Based on the convolution property of impulse. Very simple model. Which of the following signals or systems are non-causal in nature? Of course, all are system expressions. General causality of a system condition is what? General causality of a system, the present output depends on, it is function of present input, past inputs, as well as it can also depends on past outputs. For the system to be causal, our requirement is what? Present output depends only on present input, past inputs, and it may be combination of past outputs. The question asked is which of the systems are non-causal in nature? If you look at option A, yn is x of n square. Suppose I want to check n as minus 2, it becomes x of minus 2 whole square, that is x4. You are checking output at minus 2, input is needed at 4, so it is non-causal. B option, no problem, output time, input time, they are one and same. Option C, you are checking output at index n, but input is needed at n plus 1. You are checking at n, you require the next sample n plus 1. So that is non-causal. Option D, no problem. You are checking output at n, input is taken at n and n minus 4, past values. So which are non-causal in nature? A and C. A and C, they are non-causal in nature. Non-causal means present output depending on future values of the input. Present output depending on future values of the input. Average value of the periodic function is asked. What is generally average value definition? We are denoting that as A0 is 1 by t integral x of t dt, where capital T is the time period, that is area of signal over one period, area of signal over one period divided by fundamental period, area of the signal over one period by fundamental. The fundamental period of the signal is, we can take that as 2 milliseconds. 0 to 2 segment is reference, fundamental period. How to take area? Take this rectangular part area, this rectangular part area. So 14 into 1 into 10 power minus 3, lower one, minus 6 into 1 into 10 power minus 3, whole divided by 2 into 10 power minus 3. So 14 minus 6 by 2, answer becomes 4. Area of the signal over one period by fundamental period, standard relation. Area of signal over one period by fundamental. Calculate this part area, rectangular part area divided by fundamental period. Answer is 4. Okay, let us observe the next model. What is the spectrum of sampled signal is the question asked. It is like sampling theorem derivation. Generally, sampled signal is product of a continuous signal and periodic impulse train. Sampled signal is product of a continuous signal with a periodic impulse train. So where we are saying x del t is simply xt into sigma minus infinity to infinity del of t minus nts. So for getting the spectrum of this one, we are in need of using frequency convolution property. When two signals are multiplied, the respective spectrums are convolved. When two signals are multiplied, it is like multiplying the original signal with the periodic impulse train. When two signals are multiplied, respective spectrums are. So when you take Fourier transform now, xt means xf convolved with what is the standard periodic impulse train spectrum, that is another impulse train, del of f minus n into f naught. So any term convolved by impulse means it is shifted by that much amount, 1 by t sigma x of f minus n into f naught. F naught can be selected as 1 by ts, opposite to sampling period, opposite to sampling. To convert continuous to discrete or sampled signal, we are using periodic impulse train. Simple sampling theorem derivation formula. What is the spectrum of sampled signal is asked. Multiplication in time domain corresponds to convolution of spectrums. For xt, it is xf. For periodic impulse train, it is another impulse train. So final result is this, 1 by t sigma x of f minus n by t. What is a Nyquist filter impulse response expression asked? Nyquist filter means it must be a low pass filter. It must be a low pass filter. Sin a t by pi t means we are taking that as a rectangle from minus a to a, sin a t by pi t form. So this is the option. Sin pi t by t by pi t by, when you draw the spectrum, it is a rectangle for which range? Minus pi by t to pi by t, of course, with extra that capital T gain, extra capital T. So this is the highest frequency, we have omega h. So omega expansion is 2 pi fh, that equals to 1 by t, from which you can say, of course, it is pi by t. After pi cancellation, fh becomes 1 by t. 1 by t is nothing but fs by 2. So Nyquist filter nature must be a low pass filter. Nyquist filter must be a low pass filter. So option A is correct. Sin AT by pi t form, this is the standard spectrum which has the highest frequency pi by t. Omega h expansion is 2 pi fh. fh becomes 1 by 2t. 1 by t is nothing but fs by 2. That itself is FM, highest analog frequency, which is generally called as Nyquist frequency. It is generally called as Nyquist frequency. A periodic function of half-wave symmetry is necessarily. Half-wave symmetry means time domain we will say xt is minus x of t plus or minus t by 2. Its frequency domain will have only odd harmonic components like omega naught, 3 omega naught, 5 omega naught. The Fourier series expansion of half-wave symmetrical signal contains only odd harmonic components. He is saying that it is necessarily an even function, no rule. An odd function, no rule. Neither even nor odd, it can be. Because if I am choosing a signal like this, it is perfectly obeying half-wave symmetry condition. Having its time period as 2 pi, perfectly obeying half-wave symmetry time domain condition. It is actually not even, of course, neither even nor odd, but it is 100% satisfying half-wave symmetry. So the question framed here is a periodic function of half-wave symmetry is necessarily. There is no rule that it must be even or it must be odd. Neither even nor odd. Maybe certain combinations you can have even plus half wave, odd plus half wave. But a half wave symmetrical in time domain need not be an even function or odd function. The only thing we must be thorough here is half wave symmetrical signal contains odd frequency components, odd harmonics. It will have odd frequency components. Okay. This is also one of the very good question we have. ISRO it is given later on gate 2 to 3 times it is copied, this particular question. What is the data? A signal Sinc alpha t is given to another LTI system that is also represented like Sinc beta t. It is represented like Sinc beta t. So the resultant output is like K Sinc gamma t with gamma as minimum alpha beta, maximum alpha beta, like that the question is asked. So for your understanding, let us take one simple example to answer this question. Suppose I am taking Sinc t convolved Sinc t by 2. Normal Sinc x expansion is sin pi x by pi x for us, standard form, sin pi x by pi x. So this can be written as sin pi t by pi t one term convolved with sin pi t by 2 divided by pi t by 2. Just now we used in one of the example, sin a t by pi t is Engg spectrum as a rectangle from minus a to a, rectangle from minus a to. So if I take Fourier transform here, first time the rectangle covers from minus pi to pi, convolution becomes multiplication, again sin a t by pi t form, it is another rectangle from minus pi by 2 to pi by 2 with extra amplitude of 2, sin a t by pi t our standard form. After multiplication of both the rectangles in frequency domain, after multiplication of both the rectangles, we are left with this. So the inverse Fourier of this in time domain we are writing as 2 sin pi t by 2 by pi t. If I am taking that extra 2 also in the denominator, it becomes Sinc t by 2. If I am taking that extra 2 also in the denominator, that becomes Sinc t by 2. Means the original frequencies we have chosen here are pi and pi by 2, but it has retained pi by 2. Question is framed in terms of alpha beta. He is asking whether we have retained minimum alpha beta or maximum alpha beta. Out of pi and pi by 2, which frequency we have retained? Pi by 2 is retained. So again the resultant answer is in Sinc form with the gamma as minimum of alpha beta, with gamma value as minimum of alpha beta. One of the finest questions we got. So for easiness, I have taken specific number for explanation purpose, specific numbers. Okay, let us see the next model. For a linear phase FIR filter, for a linear phase FIR filter, if Z0 is a 0, what are the other zeros that are possible? Linear phase general meaning is obeying either symmetrical or anti-symmetrical impulse response. In the case of FIR filter. Linear phase indirect meaning obeying either symmetrical or anti-symmetrical impulse response, where n is the length of impulse response. So for a linear phase FIR filter, whenever Z0 is a 0, Z0 inverse is also a 0. Whenever Z0 is a 0, Z0 inverse is also a 0. Actually, to verify that point, we need two properties. One is the time reversal property of Z transform, that is x minus n will have Z transform as x of Z inverse. Another property we need is time shifting. X of n minus n naught is Z power minus n naught into xz. So this expression, internally if I take minus sign common, so what is the Z transform for this expression means Hz equals to, this is like n naught for us, this is like n naught, n minus n naught form, plus or minus for h minus n answer is h of Z inverse into Z power minus of n minus 1. So whenever Z0 is a 0, Z0 inverse is also a 0. Because the considered signal is real signal, they can occur in conjugate pair. So you can have Z0 a root, Z0 inverse and conjugation of both. You can have Z0 as a 0, Z0 inverse also as a 0 and conjugation of both. Linear phase FIR filter indirect meaning is obeying symmetry or anti-symmetry. Linear phase FIR filter indirect meaning is obeying symmetry or anti-symmetry. Let us see the next model. What will be the minimum number of taps? Taps means delays required to realize an FIR filter having passband frequency 10 kHz, stop band 15 kHz, 0.1 decibel passband ripple means he has given del P as 0.1 decibel, 60 dB attenuation in the stop band, del S. Attenuation means 1 by gain, sampling frequency. By giving all this information, he is asking what is the order of the filter. Number of delays indirectly means order. So when you study this question, you should get the idea it corresponds to which specific window. In FIR filter design, there are two methods generally we are using to design an FIR filter with linear phase. One is named as windowing method, the other one is frequency sampling method. So for the given data, which is the suitable window, 60 dB attenuation in the stop band. So the suitable window for us is Blackman window, because Blackman case it is minus 74 decibel. See here, generally for window 4 parameters are compared. What is the transition width of main lobe, peak side lobe level, transition width means this is nothing but stop band to pass band gap, and minimum stop band attenuation. When you see the last column, minimum stop band attenuation, Blackman is the suitable one. Blackman is the suitable one because 60 dB is mentioned for us. In the question, 60 decibel is mentioned. So first we have to normalize the frequencies. To convert analog to digital frequency, the normalization formula is 2 pi f by fs. First we have to normalize the frequencies. So omega pb is nothing but 2 pi into 10 by sampling rate is given as 200, that is 0.1 pi. Omega sb is nothing but 2 pi into 15 by 200, that is 0.15 pi. 0.15 pi. So first we got the respective digital frequencies omega pb, omega sb. To get the order, what is the formula? Del f is 5.5 by n. So del omega is nothing but 11 pi by n. Del omega is the transition width, which is nothing but omega sb minus omega pb. Omega sb minus omega pb. So to get the order, it is 11 pi by del omega. That is 11 pi by, what is del omega? Difference between these frequencies, 0.15 pi minus 0.1 pi. So it is 11 by 0.05, 220. 220. So to answer this type of model, compulsory you must be thorough with the comparison of window characteristics table. So I have provided the table. This is a favorite model in ISRO examination. In one of the exam, peak side lobe level is asked for rectangular window, which is minus 13 decibel. So this is the most important one. So when you see the problem data, first thought we need to answer this question is 60 dB attenuation in the stop band, which is the suitable window based on the standard table. Blackman case it is minus 74 decibel. Then you have to normalize the frequencies. Digital frequencies must be available in the range minus pi to pi. First you have to normalize the frequencies. After that, what is the transition width formula for Blackman? 5.5 by n in terms of omega 11 pi by n. Calculate. We got the order. We got the order. So one of the finest question that is given in ISRO. Please concentrate this table. Those quantities will never change. You may get object question related to this table, comparison of window characteristics. So this is one more example that is asked. Some pole zero plot is given. It corresponds to which type of filter? So we have complex poles, but 1 0 is there. Here also complex poles. Assume them like P0, P1, P2. Assume them like P0, P1, P2. They are like conjugate. So you can write the transfer function as only 1 0 s divided by, we have a 0. So s minus P1 into s minus P1 conjugate. First I will start with P0. Then s minus P1 into s minus P1 conjugate. S minus P2 into s minus P2 conjugate. Generally, to know the nature of the filter in S-plane, we are checking for starting and ending value. What is limit s tends to 0 h of s here? 0 by something, s plus 0. Limit s tends to infinity h of s, also 0. If you take that common multiplier of s terms, so it is almost s power 6, 1 by s power 5, 1 by infinity is 0. Starting ending 0 means it is a band pass filter. With respect to S-plane, starting ending 0 means it is a band pass filter. First you write the transfer function from the given pole zero plot, then you can answer it easily. Check starting value, ending value. S tends to 0, S tends to infinity. Let us see this model. The 5-point DFT of a sequence yn 1, 2, 3, 4, 5. Signal data is given as 1, 2, 3, 4, 5. Its DFT is mentioned as yk. Then what is the DFT of y of k? Means when you apply 2 times DFT to the signal, what is the answer? That is the question. So indirectly it is DFT of yn. That is n into y minus n, which is circular reversal. Length is 5. Length is 5. Total 5 samples are there. 5 into, what is the circular reversal of 1, 2, 3, 4, 5? 1 as it is, rest of the samples are flipped. So 5, 25, 20, 15. When you apply 2 times DFT to the signal, what will be our result means n times y of minus n, that is circular reversal. Circular reversal, origin sample remains same, rest of the samples are flipped. Circular reversal. Origin sample remains same. If once you are thorough with the property, you can attempt that model. Once you are thorough with the property. Let us see the next question. What is Fourier transform of a real and odd function? Fourier transform of real and odd function. Real and odd becomes imaginary odd. One simple example, signum Fourier transform is a 2 by j omega. Signum function is real as well as odd signal, plus or minus 1 amplitude, real numbers. Of course it is odd. Spectrum is imaginary and odd. When you draw the phase spectrum, you will get plus or minus 90. So there is a chance of getting, based on this point, few questions. So in time domain and frequency domain, whenever you take real and even signal, spectrum is real and even. Whenever you take real and odd, spectrum domain it is imaginary odd, vice versa, opposite also true. Real and odd becomes imaginary odd becomes real and odd. In a similar way, when you take imaginary even time domain signal nature, spectrum is imaginary. So these are the standard conditions. Here the question framed is the Fourier transform of a real and odd function is real and odd becomes imaginary odd. Real and odd becomes imaginary odd. So those are some of the other possible chances for us. What is this model that is asked is, which of the following statement is not true? Means which is false. First option, autocorrelation function and energy spectral density form Fourier transform pair. That is of course true. Rx tau Fourier transform pair with Sx of omega. Fourier transform whole square is called as spectral density. This is autocorrelation function. That is true. Autocorrelation function of a real valued energy signal is a real valued odd function. Autocorrelation is always an even function. Rx tau is Rx of minus tau. So that is the false statement. The value of autocorrelation function of a power signal at the origin equals to average power of the signal. Rx0 means area under spectral density, spectrum at 0. Autocorrelation function at origin corresponds to area under spectral density. Autocorrelation is inverse Fourier transform of power spectral density. Of course, that is also true, because autocorrelation or cross correlation can be defined for both energy and power signals. Option B is the false statement, because autocorrelation is even function of tau. Consider the signal. He has stated t less than 0, some graph t greater than or equals to 0. There only indication is there that it is non-periodic. All periodic signals are everlasting. All periodic signals must extend from minus infinity to infinity. They have to extend for all time. But here it is stated t less than 0, t greater than or equals to 0. No need to check it. For t less than 0 some graph, t greater than or equals to 0 some other graph, it is non-periodic. That periodic signal must be everlasting signal, but they are like switching. Negative time it is a sum of two cos functions, positive time it is sum of two different sine functions. Y of t equals to x of 2t plus 3, which is the correct property that is asked. X of 2t means time variant, because in general time scaling operation is a variant operation. Adding a constant number makes the system non-linear. Adding extra number makes the system non-linear. So non-linear and time variant is the correct one. Non-linear and time variant. Time scaling is a variant operation. Adding a number makes the system non-linear. A continuous time signal has frequency components 10 MHz, 50 MHz, 70 MHz. Signal is sampled at a sampling frequency of 56 MHz. So the frequency content of sampled output will be. Frequencies at the output of sampler is generally taken as Fm plus or minus n into Fs. According to our sampling theorem derivation, n can be varied from 0 to, but here we have three frequencies, three combination of frequencies are given, that is 10 plus or minus n into 56, that is one combination. Another frequency 50 plus or minus n into 56. Last one 70 plus or minus n into 56. See, n value 0 will make 10, 50, 70. N value 1 is making 66 and 46. Here 6 we will get 6 megahertz. Here 14 megahertz. Correctly speaking, individually all the options are correct, but best option is this one out of the available option. Actually all options are true, because n equals to 0 is making 10, n equals to 1 is making here 50 minus 56, that is minus 6, 70 minus 56 is 14. So best possibility is this one. So frequencies at the output of sampler is decided by which term? In ideal sampling case, Fm plus or minus n into Fs. Based on that point, you have to answer. Okay, let us observe the next one. Difference in the number of complex multipliers required for 16-point DFT and radix to FFT. So generally, if you make a comparison of n-point DFT and n-point FFT, the complex multiplications needed, here n square, here it becomes n by 2 log n base 2 for FFT. The complex additions are n into n minus 1 n log n base 2. So here he is expecting difference in the number of complex multipliers required for 16 point. So direct DFT is asking how many number of complex multiplications. How many complex multiplications for DFT? 16 square, that is 256. But if you go with FFT, we are saying n by 2 log n base 2 means 16 by 2 log 16, that becomes 32. So when you subtract, so number of multipliers saved with respect to FFT algorithm is this much. Anyway, he has asked a difference, that is 224. So once you are thorough with the standard relation, you can answer it. Number of multiplications in the case of DFT n square, FFT algorithm, that butterfly structure, it becomes n by 2 log n base 2. Additions n into n minus 1 n log n base 2. The Fourier transform of a Gaussian pulse is again Gaussian standard relation. When you take e power minus at square form, the fixed answer is root pi by a e power minus omega square by Fourier. When you take Gaussian function in time domain, in frequency domain also again we are getting Gaussian spectrum. Fourier transform of Gaussian means again it is Gaussian. What are the benefits of bandpass sampling over low pass sampling means it reduces the speed requirement of A to D converter 100% correct. One example to tell you, suppose 80 to 100 megahertz we have selected a bandpass signal. If you are applying ordinary low pass sampling, minimum 200 megahertz sampling rate is needed, minimum 200 megahertz. But with bandpass sampling concept, even with 40 megahertz, we can recover back the original spectrum, even with 40 megahertz. So, both the statements are true here. It reduces the speed requirement of A to D converter because it is reducing the sampling rate. It increases the amount of digital memory necessary to capture a given interval of signal. You are not picking the entire signal, you want to pick certain portion. So, it increases the amount of digital memory. Both options are correct. Means option C is the correct answer. Option C is the correct answer. This is one of the finest question from bandpass sampling asked in ISRO paper. For a signal with center frequency 1200 megahertz, bandwidth of 100 megahertz, which of the following sampling frequency will cause spectrum inversion? Spectrum inversion means positive baseband will have inverted shape of negative baseband. Positive baseband will have inverted shape of negative baseband of the original spectrum. See, generally we are choosing bandpass spectrum something like this, FL to FH. He has given center frequency how much? 1200 megahertz. Bandwidth is given as 100 megahertz. To avoid spectrum inversion, optimum sampling rate is 2 into Fc minus B by M even. So, 2, 4, 6, those are the valid numbers. To avoid spectrum inversion, optimum Fs is 2Fc minus B by M into M even. We have to choose only even index 2, 4, 6 like that. So, when you substitute the data, option D will fail that. Rest of the ABC options will get. So, let me tell you, suppose I want to take M equals to 2, sir. For M equals to 2, what is that optimum Fs? 2 into Fc means 1200 minus B 100 by 2. That becomes 1150, 2400 by 2400 minus 100. M equals to 4 means same optimum Fs becomes same answer divided by 2, that is 575 megahertz. If I take M value 8, same answer divided by again 2, that is 287.5 megahertz. So, to avoid, we are using this formula to avoid spectrum inversion. But what is the question asked? Which of the following sampling rate will cause spectrum inversion? See the options. First we got 1150. Because M must be even number 2, 4, 6 like that. 1150 by 2 again by 2. So this is a failure. 1600 megahertz is failure. Spectrum inversion general meaning is positive baseband will have inverted shape of negative baseband when you draw the spectrum. When you draw the spectrum. This is a very good question. Let us see the next model. Some input signal is given sin 2 pi into 4000 t plus 0.75 sin 2 pi 5000 t plus pi by 4. That is sampled. Later on, we want to take 8-point DFT from that. The DFT formula is also given. What is capital X0? That is the question. Funny thing about this question is, without solving you can say the answer. Meaning of X0 is xk at k equals to 0, DFT spectrum at k equals to 0. Because both are sine functions, they will have shifted impulses. Because both are sine functions, even if you do sampling, t place NTS conversion, all that, they will have shifted impulses. So spectrum doesn't have any value at origin. For your understanding, suppose we are choosing cos 2 pi by n k naught n. The standard DFT result is, it will have two impulses at plus k naught minus k naught in frequency domain. Sin 2 pi by n k naught n. That will have again two impulses n by 2j minus n by 2j. When you look at the spectrum very clearly, there is no value at origin. Where the answer is expected? You are sampling that sine function, answer is expected at 0, xk at k equals to 0 is asked for the given question, answer is. So with common sense you have to answer this question. It's not that t is replaced as n into ts and picking all those samples. Spectrum at 0 is asked. Both are sine functions, they will have shifted impulses, no value at origin. There is no value at origin. Okay, this is also one of the simple question that is asked. Input sequence set of 1, 2, 3, 4, 5. Okay, passed through LTI system with impulse response. What is the output of the filter? In linear convolution, we are aware input has m number of samples, system has n number of samples, means length of the output will be m plus n minus 1 samples. So in our example, it is 5 plus 5 minus 1, that is 9 samples. Input is given for 5, system is given for A and B can be eliminated. Choice is between C and D. When you do that convolution, let us verify the first sample by using sum by column method. If you multiply 5, 10, 15, 20, 25, next 4 multiplication means 4, 8, 12, 16, 20, like that the process will go on. Our first value 5, first value is 5. So out of C and D, blindly which is correct answer? Option C. Starting sample amplitude must be 5. Actually you have to complete the example, no need. ISRO is a time bounded exam, you cannot waste your time. First logic we need is input has m sample, system has n sample, means length of the output is m plus n minus 1. For the given data, 9 samples must be there in the output. Eliminate A and B. Choice may be between C and D, but our starting sample is 5. Starting sample is 5. Option C is the correct answer. Okay. Consider a signal V of t with a Fourier transform Vf, then Fourier transform of V of 2t, scaling property V of 2t is nothing but 1 by 2 V of f by 2. Scaling property of Fourier transform, x of alpha t means standard result 1 by mod alpha x of f by alpha. So it is magnitude scaled by 1 by 2 and the spectrum is expanded. How? Let V of f spectrum is like this. Let V of f spectrum is like this. V of f by 2 spectrum is, the bandwidth is expanded. Bandwidth is, so magnitude scaled by 0.5 and bandwidth is expanded. Same property, theoretically statement is given. Property. A discrete time LTI system with input sequence xn, output yn is characterized by this expression. If the two such systems are connected in series, which of the given difference equation is correct? Yn equals to 0.1 xn plus 0.9 y of n minus 1. By applying Z transform, if you solve the transfer function, answer is 0.1 by 1 minus 0.9 Z inverse. But he is saying two such systems are connected in series. They have same transfer function, system 1, system 2. They are connected in series. Indirectly it is h square Z. Transform domain, it is product. So 0.1 whole square is 0.01 by 1 minus 0.9 Z inverse whole square, which is like yz by xz. Yz by xz. So let me avoid that confusion. Let me write that product as gz for you. Because you are multiplying the transfer functions, h of z into h of z, same result. From that you form that expression. So yz into 1 minus 1.8 z inverse plus 0.81 z power minus 2 equals to 0.01 xz. After taking inverse Z transform, what will be our expression? Yn minus 1.8 y of n minus 1 plus 0.81 y of n minus 2 equals to 0.01 xn. Option A. It is stated that two such systems are connected in series. So transform domain, it is product, this multiplied by the same term. So 0.1 whole square is 0.01, denominator you expand, cross multiply, that is forming that difference equation. Okay. A DSP system is described by this expression, the system is it FIR or IIR, is it stable or unstable, that is the question. When you take Z transform here, YZ equals to 2XZ plus Z inverse into XZ plus 2Z inverse YZ. So what is the transfer function YZ by XZ? Transfer function YZ by XZ is 2 plus Z inverse by 1 plus. Of course, it is a causal system but having pole at Z equals to minus 2. Both causality stability means we want pole inside, but the pole is outside, so it is unstable. Pole magnitude greater than 1. It is an IIR filter expression. It is an IIR filter expression. The considered transfer function is causal. Both causality, stability in the jet plane means poles must lie inside the unit circle. But here the pole lies at z equals to -2. So it is unstable. It is IIR filter, infinite impulse response filter expression. Why I have provided this table is, in I think 23 ISRO exam this question is asked. Recent times. The given butterfly, this particular phase factor will exist in which stage? Log n base 2 stages of decimation will be there generally. So this particular phase factor will exist in which stage, that you can answer based on this. Generally in FFT there are two types of algorithms, DAT and DAF. Decimation in time means phase factors are multiplied before. Decimation frequency, phase factors are multiplied after. So if you are in a position to be thorough with these things, stage 4.2 8-point conversion, 8.2 16-point, then you are in a position to answer that. So I have given a clear solution for that. Later on you can cross check for each stage. He is asking W32 power 6 is there for which stages? That is for last two stages. Here we have W32 power 6, here also we have W32 power 6. Okay, last two stages. Similarly, this table I provided because there is a chance of getting few questions related to Butterworth and Chebyshev comparison type. Butterworth filter has maximally flat response both in the pass band and stop band. It will have all pole. Chebyshev can maintain ripples in any one band. This comparison based theoretical questions you may get. Very old ISRO papers, those questions are there. Have a glance of this slide. Butterworth, Chebyshev, elliptical, Bessel. Please study that comparison. It becomes easy for you. So these are few models which I want to discuss. Thank you for attending the session. All the best for your future. Thank you.